Hello and welcome to Learn Synthesis with Pure Data, Season 1, Episode 6. Today we're going to be making an amplitude envelope for our synthesizer. Okay, so what is an amplitude envelope? Well, we're going to look at and make the probably the most common type of envelope out there for amplitude. And to illustrate this, I'm going to show you a graphic here. Now this is just a web search of images for ADSR envelope. And this is what I got, and I selected this I selected the other image there, but this is a little bit bigger, a little more clear, so we'll use this. Now, amplitude, as you know, kind of directly relates to the loudness at which you hear something being played. And we're basically going to make an amplitude envelope that works with the MIDI controller setup that we made last time. And so when a note gets pressed, it's going to go, its amplitude is going to have this type of shape to it. And we're going to be able to control the parameters of this shape with some controls that we're going to make. So basically what we have in an envelope, first of all, is what's called the attack. And this is how quickly does the sound come in? How quickly does the amplitude rise to what's called a peak amplitude value? Well, basically, we're going to have a control that we set up to control how quick this attack is. It could be slow enough that you might even hear this as a fade in, or it can be so quick that you hardly hear it rise in at all. But we do need to have it rise in so we don't create that artifact sound, that snapping sound that's created when sound suddenly comes on. So we do want a little bit of a slope in to our sound starting. And then there's a segment called decay. And this we will also control. How long does it take to go from this peak amplitude value down to a sustain level, meaning a level at which the amplitude of the sound will be while you're holding the key down. And basically we'll set up something like this where you can control where the sustain level's at. You could have the sustain level even just be equal to the peak amplitude so that when the attack comes in, there isn't really a decay. It basically will sustain at the same level. Or you could have it go down lower, which allows you to have a bit more of a pronounced attack, like a da, some sort of, pronounced beginning to the note. And then we will set up a release time, which is how quickly does it take for it to release from whatever the sustain level is back to silence again after you release the key. And we're going to put in a couple other things to make sure that we don't get any glitches in the sound. But this is why this shape is called an ADSR envelope. Attack, decay, sustain, release, ADSR. And envelopes, by the way, can be used to shape other things in synthesis. You could have different types of modulations and effects and other things shaped by an envelope. And of course, there are other envelope shapes other than ADSR. But ADSR is the most common because it seems to be the most useful for, starting and ending notes and controlling what the general sustain level will be of your note. So anyway, now that that's explained, let's make it. Oops. Let's get this out of the way. There we go. So here's where we left off last time. Basically, I just moved this amp mod unit over. We will be using this in our synthesizer, but that's in an upcoming episode where we'll actually put this in the signal chain so that we could actually add some tremolo effects, a little bit more amplitude shaping. But for now, I'm just moving it to the side here, or I could even move it further to the side because it's not going to be part of our synthesizer just yet. And right here is where I'm going to put a subpatch for our amplitude envelope. Now what I'm going to do, zoom in here, is make the subpatch, and then we'll size it. So remember, subpatches are basically when you make an object, type PD and then a name for your subpatch. One word, and I like to use all lowercase, just keep things consistent. I'm going to call this ADSR _1. Just like this is OSC _1 for oscillator, this is our ADSR envelope _1 that will be used in conjunction with this oscillator, because we will be making another oscillator in this series. Because in synthesis, a lot of times it's good to have two oscillators. Gives you more that you can do with the sound. So anyway, this is the blank window that opened up when I made the subpatch, which can also be called the child patch. Now this will cover up the parent patch, the main patch for now. But that's okay. Remember, we can just hit Control W, Command W in Mac to just close this window and get back to here. But right click on this and open it up so that we can make our graph on parent viewable area for the subpatch just like the others. So I'm going to right click, go to properties. We want a graph on parent, and I'm going to make it the same size as the other modules. The width in X values is 160. And the height, which is a Y value, will be 270. And you'll see our nice little red outline for that window there. And if we close this now, Control W, Command W in Mac, you see we have it here, but it looks like I made it taller. I must have entered the wrong Y value. Looks like it must be 250. I'm just guessing, but that's probably what it is. Or 260, excuse me. That's probably it, 260. And that means the width is probably 160. I tried to memorize them before I started this episode, but it doesn't look like I memorized correctly. Well, let's look at this here. Let's look at the other one just to make sure we're accurate. So I open up the other subpatch, right click, go to properties, and it is 170 by 260. Should have done that to begin. Well, I did before the episode started, but I got them. 170 260. Very good. Now, what we're going to need are controls for the attack, decay, sustain, release, and then one other that I will show you in a minute. If we look in the put menu, we're going to make controls that are vertical sliders. I don't know that we've made one of those yet. Oh, I think we did when I was demonstrating additive synthesis for the first time. But anyway, it has a shortcut, Control-Shift-V or Command-Shift-V in Mac. So here we have our slider. Now sliders have properties, and I'm going to change its properties. I'm going to right click on it, go to its properties. I don't know about height and width. I'm probably going to change the height, but let me change something else first and then I'll explain why. And then you also have a width here. Basically we'll adjust that if we need to make the different sliders that we're going to make fit and look nice. So what I'm going to change though first is its range. It comes out with a default range of 0 to 127, making it a useful default for MIDI, because so much of MIDI has a range of values between 0 and 127. But we're going to make its range 0, although we won't really want it to go to 0. Let's make it 0.01, because if our attack time is able to go to literally 0, we can get an artifact in the sound because there would be no attack time. So we don't want it to be able to go all the way to 0. And then the upper limit of it, we're going to keep this in percentage formats. So we're going to have a bottom of 0.01, meaning like 1%. And we're going to use 1, which symbolizes 100%. Or basically, numerically, that's what 100% is. The word percent meaning per 100. And so everything that's 1% is really 1/100th, which is 0.01, 1/100th of 1. So this makes it easy for us to then shape amplitude and have a good, numerical range go by as far as how we are shaping amplitude, since it's also on a range of 0 to 1. Except we don't want to go to 0 on attack time. Send and receive, yeah, we're going to have send and receive symbols. So we're going to call this, first of all, since it's an ADSR 1, I like to put the module name in some way at the beginning of symbol names for everything within that subpatch. And you'll see why later, because it makes it easy for us to have multiples of some of these subpatches and having them renamed. So ADSR _1 _ attack. And I could just say attack like that. And then underscore send, because this is a send. ADSR _1 _ attack _ you type receive, or I just like to abbreviate RECV. I don't know why, it's just a habit of mine. And then I'm going to label it attack, but this label, the most convenient place to put it is like right above the slider. And in that case, the whole word attack would be a little long. And typically when you see 4 sliders in synthesis, all you have to do is put ADSR over each of them, and somebody will know what they are. They know synthesis. And that's why I'm teaching you this way, so that you can look at other plugins, and when you see 4 sliders and they say ADSR on it, you know exactly what it is. Okay, so that's it for now. Oh, wait a minute. Since it has a range of 100, well, actually, how many values do we have? Yeah, 0.01 up to 1, if we consider it as just 2-digit numbers. You could say, let's give it a height of 100, and then basically you have 100 pixels, and you could really literally select any of those values if you're really careful with them. So I'm going to make its height 100. Oh, wait a minute, that's width. I think that was 15 to start, so I'll put it back. Height is here, and its height was 128, so you could literally go from 0 up to 128. But we've changed that range, so we're going to make it 100 pixels tall. So you can literally go from 0.01 up to 1 and select each of the values in between. Now, if you had a different height, it would still give you how many pixel values you have as far as what you can select. And you just get numbers that have, more than just 2 digits after the decimal point. You get a different range of floating point numbers in between. But I like to keep it 2-digit in case we make a display for it, so that it would display the actual value and the display would look nice. We could probably just use a number box and have a display of its values. And yeah, we'll do that after we set up each of these. I'm going to just select this, hit Control-D to duplicate, Command-D in Mac, and this will serve as our decay slider. Now I need to change its properties. We're going to keep its value range the same, a percentage rate. And we're going to label it D. And this is where you got to make sure you don't make typos when you're changing things. Tac, we'll take that out and just say decay. But everything else in the label will be the same because it's in the same module, so we want ADSR 1 at the beginning. And send a receiver. That should take care of that, so I'll press OK. Now I'm going to select both of these, duplicate them, so we can make our S and R sliders. Then I'll try and get these lined up. S. Now S, this is going to be different. The others are percentages to be multiplied by basically amplitude values. Kind of sculpt the amplitude and change it that way. Now the question here, do I want to be able to allow the sustain to be 0? I think 0.01 will still work well for us. Even if we don't really want there to be a sustain, it'll be so short that it would be like negligible. So I'm going to leave things the same except for, of course, the symbols for send and receive. We need to say sustain. And anything with its received. Okay. Good. And then the last one is going to be and now what we can do is just change this to release over here. Sorry, I was thinking ahead. I should just keep thinking about where I'm at right. Okay, good. Now, I could spread these apart to distribute them a little bit more evenly. Or we don't necessarily have to have it be the same height as the others. But, let me think here. I have an idea of what I'm going to do. Let's even these out a little. Let me leave a little more space at the top in case the name of this subpatch, well, it should only stretch out to here, but give it a margin like the others to make things look a little more uniform. All right, there we go. ADSR, that looks pretty even. And now what I'm going to put is another vertical slider here. Originally thinking of making it a horizontal slider, but we can make it a vertical slider here. Now this is going to give us a different range. I'm going to just use a shortcut here. Whoops, hit the wrong thing. That's a canvas that I made. Talk about those later when we start decorating this stuff to make it look nice. Control Shift V, there we go. Now, I'm going to right click on it, properties. This thing is going to be called DUR, D-U-R for duration. Meaning this is going to give us an ability to make the duration of the overall envelope larger or smaller depending on what the user wants to do. And this is going to be expressing a range in milliseconds. I'm going to make its range 0 to 1000, which means our maximum length for any segments, your attack, decay, or release, because those are the time segments. Sustain is a level segment, and this will last as long as you are holding down the key. So we don't have this controlling time. This is just to say how strong is this portion of the envelope compared to the initial attack value, which reaches the peak amplitude. Now, in order to give us more control over the envelope, I'm making this duration thing so that you can kind of make the overall envelope have like a multiple that it gets multiplied by to kind of control how many seconds each segment is, or how many milliseconds actually each segment is, at least the A, D, and R. The S is as long as you sustain the note or hold it down. So what I'm going to do here is give it a send and receive. This is once again ADSR _1 _ dir _ send. ADSR _1 _ dir _recv. And what I need to do now, its height is going to be 100, just like the others. That's fairly even with 1000, 0 to 1000, although we're not going to worry if that's divided up exactly evenly, because technically this is 1001 values, but it'll give us enough resolution if we just put it at 100. We'll put it here and kind of put it on its own so it's visually, shall we say, obvious that it is separate from the ADSR envelope. And DUR should indicate to anyone using this synthesizer who knows their synthesis that this is affecting duration. Now, it would be nice just adjusting this. It would be nice to be able to display what these values are. I'm thinking. Or maybe we'll see. It may not be necessary. We'll see if we really find, after trying it out, if we really find that it would be useful to display individual values so that the user can see them. I don't know just yet. We may not feel we need that. So anyway, here we go. That's good for now. Although, you know, there is a big space here. Maybe it'd be nice to display the waveform after it goes through this envelope. So we're going to say here, let's put in an array, and its name will be ADSR _1 _ wave. Make it a Bezier curve because that looks nicer. Everything else should be fine. Although, I just remembered, we do need to change some other properties. But one of the properties I think would be good to change here is not to save its contents. So uncheck that. because it's just a display waveform. There's no reason for it to save what was the last waveform in it when the patch closes. Next, let's make its height fit into this table here, or this viewable area. I'm going to do a few guesses and see how they go. Let me try width of 75 and a height of 75 just to see where we're at there. Okay, that fits in, but maybe a little too small. So I'll make its height 90. No, too close. Let's make it 80. Okay, and I'll move it down to make it fit better. And then we probably have a good 50 here. Or just to keep even numbers or round numbers, I don't know. Let's try 120. No, we can use more than that. Let's make it 140. That's good. Okay. All right. Now, I am going to adjust some things in our oscillator module. Close this, and then open our oscillator 1 module. So here's our new ADSR, which we didn't really make yet. Just its display, just its GUI. And what I'm going to do here is right-click on this and go to Open. Now, right now, we made a very simple conversion from velocity to amplitude control here, just so we could hear this and test it out. But now we're going to have an amplitude envelope. We don't need this anymore. In fact, it'll kind of basically get in the way of what we're doing with our amplitude envelope, which is basically a more robust version of an envelope than this is. So we're going to get rid of this. Now over here, I have a tab right displaying, the waveform here. And it was displaying the waveform after the amplitude was adjusted and all that jazz. It can still display whatever is going on in here. That's fine. But here, we're going to take out this DAC because we're no longer going to need it. But what we're going to do is make up a send, so we can send the signal here to the next module so that the amplitude envelope can shape it rather than what we had at the end of last time, which was basically put into here. Now, the thing is, I could disconnect all these cables and hook them up directly, but probably a better thing to do or easier thing to do is just put in a 1 here. That way, whatever these amplitudes are, they're going to stay the same coming through. So this was basically just kind of like a shut-off valve to turn on and off notes. Now, since it's going to permanently be on, we don't really need it, actually. We could just hook all these things up directly, but then I'd have to disconnect this, and then reconnect it to here, and all of them to here, and don't need to do that. Just put in a send, but this is a send of an audio signal, so instead of just an S in this object, we need an S tilde, because it's an audio signal. Now we got to give it a name. We'll call it OSC _1 _ out, which is pretty descriptive of what it is. It's output from this oscillator. Okie dokie. So there we go. That's the only thing we needed to change here, I believe. Now, the reason why we're not seeing anything there is, well, let me play a note. Okay. Now this won't shut off because, you know, a zero velocity doesn't turn the note off anymore. So this signal is running here, but it's being sent nowhere. It is going to the tab right, so that's why we do see it displaying. But now we're going to open this up. But probably while we do this, I am going to turn off DSP using the shortcut Control period or Command period in Mac, just so we can hook all this stuff up and not hear any unexpected sounds, interruption. So I'm going to spread this a little bit wider now, because this is how it's going to work. We're going to receive R tilde, receive an audio signal, OSC _1 _ out. That's what we sent from the other subpatch, so it'll receive here. So our audio signal is going to come in here, and this is where we're going to shape it. We're going to receive our attack time here. Receive ADSR _1 _ attack _ send. And now, since we're making this thing, let me put in a number box underneath. So that way I can see values coming in. It helps with the kind of like the error checking and debugging of this as we build it. May take them out later. But let's just duplicate this because the next one is going to be largely the same thing, except this is receiving the decay value, so we need to put in decay there. And next we're going to receive the sustain and release. So this is going to be changed to sustain. Give this a little space. And name this release. Now I did name this release, right? For some reason I don't remember doing it. I did. Yep, so we're good. So that's where these values come in. Now, the first thing we need here is this signal's coming in here, but we do need to receive our velocity. Remember that? Because that's what's going to, you know, be a trigger for all these things. And let me check what its name was. Let's right click here on the MIDI patch and see what its name is. Send MIDI vel receive, that's where it goes here. And then it comes out of here, out of this number box that displays it. And it comes out as MIDI vel send. Okay, so let's go back here. Open this up, and we're going to receive MIDI _vel _send. Let's put a number box below it so we can see that. Number boxes don't work at the audio rate, or they may try to, but there's really no value in putting a number box below this because this is audio signal. Okay, so anyway, so our velocity comes in. So now I'm going to do something here. I am first going to make an object called divide by 127, because we're going to convert this velocity into Okay, let's do this. We don't need the number box there. Let's just divide it by 127 immediately. So we get a range of 0 to 1 to begin with, an amplitude value. Next, we're going to put a number box so we can see the values coming in. I may take that out later after we error check this, because there's no need for it. And then let's see. We're going to make a select box, SEL0, because we want to have a special function for whenever a 0 comes through. In other words, the note has been released. So this will detect if the note's been released. And its right outlet, remember, will display anything that comes in that's not 0. So this is where we would get all our non-zero values coming out, which means everything else, like all your velocities when the note's being pressed, that's what will come out here. So now let's say that, a note's pressed and we want it to create this amplitude shape. Okay, so we're going to basically get an amplitude value coming out of here in a range of 0 to 1. And we're going to take a multiplier here, a star, just a asterisk. And it's going to be multiplied by what? Oh, wait a minute. I'm going ahead of myself. I forgot to put the duration thing in. Let's move the attack, decay, sustain, release over. Because our duration slider, that last vertical slider that we made right here, this governs the time multiple. Basically, how many milliseconds these percentages are going to be. You'll see what I mean in a moment. Receive ADSR _1 _DUR _send. And we'll put a number box below it so that way we can see what comes out for now. And actually, I'm going to use this now. Because our attack time is not going to literally be 0.01 milliseconds. That's, whoa, too short. The intention of using these percentages is to multiply them by a range that you decide here with DUR, which is going to be in milliseconds. Now that that's come up, I've just remembered our DUR range is 0 to 1000. I'm going to change that. We don't really want a 0 millisecond possibility happening. Although I guess we won't get it because we'll have 0.01 as the minimum for all these sliders. So if attack is set to 0.01 times 1000, we are going to get 10 milliseconds. We'll see. That might be a little short. We might still hear some artifacts. So, well, we won't find out until we do it. But if it's multiplied by a DUR that we set that's too low, my DUR range is probably, not quite right for what we're doing. So I'm going to change it. I'm going to make its minimum. Its minimum should be 1000. I wasn't thinking before. And its maximum, let's say 3000 or 5000. because we have all these percentages coming through. And 0.01 times 1000 equals 10. We don't want anything shorter than 10 milliseconds because that could cause artifacts. So anyway, what we're going to do is we want to multiply this door by attack to get an actual millisecond time span. Now, in order to do this properly, you could have door coming in here. Every time a new door value comes in, it will automatically calculate. But if you change the attack value, it won't automatically calculate unless a new door value comes in. Unless you do the following. You make a trigger, T, bang, float, TBF. What this will do is when the attack time gets changed, someone moves the slider, it'll send the number from that slider in here, be multiplied by door. And then it'll bang, oh, I hooked it up to the left inlet, that's wrong. Right inlet. And bang to the left inlet. Sorry. That bang will say calculate. So the float comes in just first because it's to the right. It'll come in here and it'll get stored, and then the bang will make sure it multiplies it by whatever the door value is at this time, even if it's not sent in. So basically it'll calculate. And we can actually see this now. I'm going to go into run mode and move these sliders. Let's even put this down to its minimum value, which is 1000. There we go. 1000 times. We need to actually do an attack value. There we go. I put it all the way down. Its minimum is 0.01. We get 10 milliseconds here. That will be our minimum attack time. Like even when you have the attack all the way down. Typically in ADSRs, when you have sliders like this, raising the slider means your attack gets slower and slower because it's really indicating a time span. If you turn it all the way up, it'll be a 1 second long attack. Looks like our door doesn't really need to be going up to 5,000, but who knows what kind of weird sounds you want to make. Really slow music. So anyway, we'll leave that in. Actually, it probably is just as useful maybe to make a constant value of 1000 for this stuff. And not actually have it be adjustable here, but I don't know. Let's see what happens. Okay, so anyway, we have that door value and we turn this all the way up. Let's just turn it all the way down. Okay, and then, so this is our attack time. This is how quickly it's supposed to go from a 0 state until to the peak amplitude. We're going to put a star tilde here. This is the overall amplifier that's going to govern this signal. So here comes the signal here. Here's our sound coming in. It'll go to the left inlet here. And this is how quickly it'll go to what? It'll go to the peak amplitude, which will be coming out here. Now this stuff needs to be sent as a single message. ACK, we've done this before, F this time, meaning 2 floats. This pack is going to receive turning the note on and what amplitude it's going to go to and over how many milliseconds. And that'll go through a line tilde object, which, as we've been using before, will ramp up to this value over this many milliseconds. And this is the one that we're going to use to feed everything from this amplitude envelope. Now, out of here is the node off, but we're going to deal with that in a bit. Let's make the rest of this. Okay, so how about our decay time? Well, that's going to need this stuff again. We're basically going to need the same equipment here, same objects. Move them on over here. We're going to have the door time multiple. Whoops, right here, left inlet of the multiplier. Have it get multiplied by the decay amount that we set. Okay. And this will give us our decay time. Now, what's going to actually happen is, let me get that. Do I still have that picture? No, I don't. But basically, when the sound comes in, just follow my mouse here. We have our attack that goes to the peak amplitude. What we got to do now is say, how long does it take to go down to whatever the sustain value is? So we need a sustain value. So here we have the sustain value as a slider that is going to say how much of the peak amplitude value is the sustain value going to be? What percentage of it? If you turn it all the way up, it'll be 1 times the peak amplitude value, and that means it'll be the same. But any gradient below that, it'll be a percentage multiplied by the peak amplitude value, thus reducing it. And so we're going to need the same equipment again to do that. Because once again, it's multiplication. And the reason why we use the trigger bang float is so that if sustain is altered, it will do the computation, because the star tilde, I mean, not star tilde, but the star object, the multiplier object, like all the other math objects, doesn't automatically calculate something that comes into the right inlet. Whatever's coming in the right inlet is to be multiplied by whatever comes in the left inlet. It'll only do that when something comes into the left inlet. So if something new comes in through the right inlet and nothing new comes into the left inlet, it doesn't do anything unless you bang it. So this trigger bang float will bang it to make sure that if you adjust the sustain value, it will do the calculation and find out what the amplitude value actually is. So we can take this guy out of here and connect it up here as well. Okay. Let's leave it up there. Fairly obvious that this is going to here. It's going from the right outlet here. Got to be the right outlet, not the left outlet. The left outlet is just to bang if there's a 0 value. Maybe I should move this down a little bit lower just so it's clear that it's coming out of that. There we go. Okay, so now we're going to say over the decay time, it's going to go to this value instead. So that needs to be packed together as a message. So this is the amount of time that goes into the right inlet. And the value of the amplitude that it's going to is going into the left inlet. Now, hold on a moment. The only time you want this going through is when we get to it. So we need to change something here. And I knew this was coming, but I hooked this up anyway just to show the logic. But we're going to have to change this a little bit. We're going to disconnect this. Remember, this is the attack time, the actual time that's going to take to rise to this amplitude value. We do want it going there, and we will hook it up again, but we want to do the following. Trigger, bang, float, TBF. And now we'll hook up the float, which means the number that's coming through, the number here comes out here. But also it sends a bang. And what this bang is going to connect to is a delay object. Delay. I'm not even going to put in a creation argument. Delay simply means when it receives the bang through its left inlet, it'll delay and wait however many milliseconds you put as a creation argument, or send in the right inlet. It'll wait that long before it sends out the bang out the outlet. And that bang is what we're going to use to initiate this. Okay, so in order to do that, we're going to need this float value here as well as there. See, it's going to be going there, but it's also going to tell it how long the attack time is. So this is delaying for the attack segment to finish. The attack goes from 0 to whatever this amplitude value is over this many milliseconds coming through. And when it gets there, this delay time will have expired and the bang comes out here to initiate the next segment. Now what we're going to do is the following. You can leave this like this. I need to put a float box here. Remember the good old float boxes? They store numbers in them when you hook them up to the left, to the right inlet, sorry. And what that means is it's storing that number, meaning the sustain value, but it's not going to send it until it's banged. In other words, it won't send it until we have just finished the attack time segment. That means we can now send the decay segment, meaning go to this amplitude value, which is the sustain multiplied by the peak amplitude, meaning the amplitude that comes in as a result of the velocity, which gets stored here. And it's like it'll go to that over this many milliseconds, but this only gets initiated after we've waited the attack time, because the float box stores the number, and when it gets banged here, it'll send it out. And the pack works similarly, where since this is packing together two floats, two numbers, the right inlet doesn't initiate sending out the numbers, it just stores it. So the decay time will be stored. And then here, when this gets sent, then both numbers get sent, and they'll be sent to line. So let's move this down. So this is the pack for the attack segment. Put it here. This is the pack for the decay segment. And hook it up. Now there's one more thing we do need to do. And this is because I've made these plenty of times in the past. Well, not one more thing, but I mean one thing that we need to do with this section here. But you know what? I'm going to add it later because I want you to see why we'll need it. Okay. And the next thing is, after this thing's sustaining, when the note gets released, that's when we want to execute the release time, which is like a fade out on the note. And then once again, for the release, it's going to be that percentage, the 0.121 range. of time multiplied by our Dura time. So like everything else, it's a percentage of the overall Dura time. So that comes in there. And where's our Dura time? It is here. Oh, I need to make the, oh, I did make it. There it is. So, yeah, here's the Dura time. Take this, go to the left inlet of the multiplier. Right inlet's hooked up. So here we get what will literally be our release time. 1,000 milliseconds or whatever the Dura is set to times the percentage that comes through from the release slider. Okay. And now, what we're going to send as a result of that is going to be the following. Pack 0 F. So in other words, it's always going to send a 0 as the first value because that's the amplitude we're going to. When the note's released, we want to go to 0 amplitude. And the amount of time it'll take to go there is defined by this. Now, what executes it? Well, first of all, the note needs to be released in order to execute. Because whenever you release the key of the keyboard, that's when you want the note to go off or turn off. I just like to adjust things. Oh, jeez. Make these straight, kind of. Okay, so what initiates that is here. Coming out here is a bang when that 0 occurs. Now, the thing is, I know I'm going to have to do something else, but I want to show you why. So I'm going to just hook it up here anyway. So yeah, we get a bang out here because we got a 0 coming through. That means we have had the key released. We have 0 velocity. That means the note's off. It's time to send this through. And this is going to go to line. Alrighty. Now, what we're also going to do to visualize this, well, we're going to visualize it and hear it. So first of all, we're going to make tab right tilde. And what is it? ADSR 1_wave. Very good. This goes in here, but remember, in order to write, in order to make sure it's continually writing, we need a metro banging it. Metro 100. Now, do we want to toggle switch? Well, we need to be able to turn it on. But in the other patches, remember what we did? We had an on and off switch for it. Will it fit here well? Probably make it look a little cluttered. But we definitely do want it on. So what we're going to do is just make a load bang and a message of 1. Or 1 turns on metro. And what I'm going to do is go into run mode and just turn it on now. Click. Now, of course, it won't run until I turn DSP on. Remember, I turned that off before. So we turn it on. Now, I need to, since these sliders haven't been moved yet, I need to move them. I'm going to have minimum sustain and release times. I mean the decay and release times, but the sustain value I'm going to make a little bit more than halfway up. So there we do see the sound, and it does release. but we want to hear it to make sure it's nice and smooth. So we're going to make a quick DAC because we need to hear its output for now. DAC tilde. And hook it up to both sides so we hear it out both sides. Now I'm going to press the key. Now I'm hearing the snaps. I do hear a snap, especially at the beginning. Turn up the attack time and the release time. I'm still hearing it snap off. What is the release time that's coming in? 0.11. But it's still 0 here. Oh! These number boxes are still 0. That's why it's good to put them in when you're making something so you can error check it. The reason why is this stuff never got multiplied by door, because I never moved the door slider after making them. There we go. No snaps now. Let's see if we could turn them all the way down and not have snaps. I'm not hearing an actual clear artifact. The release is a little bit tight though, but turn it up some. Hear how it releases slower now? Now we'll hear it come in a little slower too. Okay, now I'm going to turn up the decay time. This means how long does it take? I'm going to turn it up significantly, so hopefully we can hear a clear difference between the peak, like when the attack comes in, and then when it lowers down to the sustain level. Hold on here. Let's make it quick and make the sustain level significantly different. You hear that? Woo, woo. That's the, we turn up the decay time, we'll hear a longer, louder pronounced beginning coming down to the sustain level. Let me see. I'm not really hearing it that clearly. 780 milliseconds is our decay time. That's nearly a second. The attack time shouldn't really affect me hearing this. Let's just, maybe also it is a sine wave, so. I think we have a problem here. Yeah, this is such a small fraction of it. We should really hear the difference and see it in the display. So let's look here. Here's our door coming in. Oh, not door. Here's our amplitude coming in. We took the right outlet there. It's going into the multiplier here, TBF. Our sustain is at 0. That means we probably have a symbol disagreement. Our ADSR _1 _ sustain SUSTAIN _ send. Let's go to sustain here. SUSATIN. That's why also I put these number boxes in to debug things at first. Now I need to actually move the sustain slider for it to take effect. I'm not seeing it do it. But our sustain is coming through. It's a value of 0.13, getting multiplied by this level here. And it's saying here, at least at the output, 0.121. That's a pretty low amplitude, so we should hear that. It's stored in the float box here. And it comes out after the delay has been reached. And the delay is the attack time. This is where the attack time is being calculated. Right here. The attack time's coming in. So after the attack time, it should start going down that amplitude value. The sustain level is significantly different than, and it's showing it here. This is a pretty low amplitude. Being stored here, being banged after the delay. Which is sending the number here to pack FF. Means it's going with this 780 milliseconds to get to that level, going into line tilde. Let's try something here. I'm going to put in a creation argument. Okay, let's see here. Getting this, but now let me see here. Yeah, this is supposed to be the first number. I'm going to put a number box here. See that it does come out. And of course, since it's going into the left inlet, it should execute this pack message to send to here to go through line. It's not coming out. Why is that? 1,000 milliseconds is 1 second. But of course, this gets updated with the value from here, which is 120. 120? My goodness. This is door. Oh my goodness. This is why. Folks. I thought I was hooking it up to this. I was hooking it up to this. This value here This is door times, wait a minute. Hold on. No. Yeah, the wait time for this should be, no, I had it right. This should be 120 milliseconds times, the attack. 1000 times that is 120. Okay. Create the TBF again. Yes, this should not only be, yeah, let's do this. Let's make it TBFF. Same float should come out both times. So the one float comes out here, meaning this number 120, as it is right now, comes out there into delay. It also comes out here into pack. Now I had it hooked up right. But I'm not seeing this come out. Here's 0.007. It's getting stored in float here. The float is hooked up to delay. Delay is getting banged. After 1,000 milliseconds, which is 1 second, that's its creation argument right now. And when this comes in, it would even be sooner. Make the decay time longer. I turned, wait a minute, that's sustain. No, that's attack. I made the decay time longer so we could, well, we don't need to hear a long fade out, but this is about a second almost. So anyway, so yeah, we should hear, make the attack time longer. Okay, I'm hearing it fade in with the slower attack time now. I'm hearing it fade in slower. Oh, this did come out this time, but it says 0.009. But I'm not even hearing that. I'm not hearing it go down to that value. Oh, actually, part of what I was thinking before is the problem. No, that's the delay time. Never mind. No. Yeah, that should be the delay time. The attack time should be how long it waits before it bangs this float box. Now I'm finally seeing that a number comes out. Not the same number that's going in, mind you. Well, no, it is. I'm not hearing it go down to that level in amplitude. Any errors over here? No. No errors over there. I've done this before. Now, the thing I was talking about adding to this didn't even really come up yet. But since I'm kind of stopped right now, I might as well at least put that in. one thing that I had noticed in the past, not happening now. In fact, it's not quite working right now. Yeah, that's the signal to turn off notes. Going here to this pack message. I'm trying to highlight it blue and have it stay blue. Not for some reason. Oh, it is. Sorry, I have these blue light glasses on to screen my eyes, and that's making it not blue. Okay, so yeah, that's going through. I mean, we're having no problem with the release. It's just the decay down to the sustain level that's just not happening. Wow. And usually what the problem was in the past is the decay would not stop if you released the key too early. So I had to put in something to turn on and off the decay so it would get out of the way if the note got released too early. But right now, we're not having that, because we're really not having this decay segment at all. So our numbers are 0.01 here, 0.88 here, multiplied, so 880 milliseconds, the amount of time for it to go to this value here, 0.0009. And it's going into the left inlet of line. Make sure, yeah. That is strange. Now the sustain level is this number coming in multiplied by, yeah, make sure it's hooked up to the right outlet here. Is the right outlet. Going into here. I mean, I should see this. Those are very small ranges of numbers. Let me do this. Still be very low in value. I'm not seeing it come out here. The delay should be over 1,000. Here we are getting attack time, the same value that's going here for the attack time. Now, what is the attack time? 0.73. Yeah, total is 730 milliseconds. That's less than a second. Figure BFF. So this does bang here. Here, I'm going to put in something. Control Shift B. It's a display bang. To see if this is actually going off. Because it's strange, the number under the float box is not changing, and I don't know why. delay does not seem to be working. Let me do this. I'm going to make another one. Oh, that was V. Let me see here. Okay. So I'm seeing the bang getting delayed, and then I see it happen, and we heard the note. And it was a low level of amplitude. That was a sustain level. It did get executed after I hit this. But how come oh, I know why. All right. I'm going to do this just so this doesn't get too complicated here. It's not happening because it's being timed by the wrong event. The bang that it's receiving is not the right bang. Hold on here. Bang, float, float. Okay, here's where the velocity comes out. Well, the velocity on and its value becomes amplitude values here, and it comes out here. Let me move this further down so it doesn't get confused with that cable. Let me get rid of these guys here. Hook this up directly. Okay. The thing is, this delay is being banged when the sustain gets changed, not when the note comes out. Okay? So I'm going to change this. Doesn't need to be a trigger anymore, really, but let's make it a trigger float. So it goes here and the float, meaning the sustain, the decay time, or not the decay time, the attack time. The amount of time it takes for the attack segment to take place not only goes to this pat message, along with the float, and I'm going to use the left one. Of the two floats. This float also goes to where? It's over here, this multiplier here, to be multiplied by the sustain level. Calculate what the sustain level will be. Okay, and then this bang here, which happens when the key gets pressed, that's what's supposed to bang delay. Now, something's still hooked up to delay here. We want it to receive in its right inlet the amount of time to wait. Okay, so it gets that. But its left inlet is where it receives the bang that it delays, and that will be. Okay, let's try it. There we go. Woof! you got to test things out. You got to try things before and after, but you follow your signal lines of what things are happening at what time, and just keep looking until you find something not responding right. I put those bangs in and I could see that the mechanism was working. It just wasn't being banged at the right time. And yeah, I mean, the reason why was because this is what should instigate the timing. Because when the note's pressed, this delay should be waiting the amount of time of the attack time. So when the attack message is sent, this is waiting until it's finished, and then that's when it sends the decay message. Now, let's see if it releases okay. Hear that? That's what I was talking about before when I said there's something else we need to do. If you release, hold on. There, it releases fine. See, if you release while the decay or before the decay gets sent, it won't stop the note. So we need to make a mechanism so that the decay message can be turned off whenever the release happens. So that's why I said earlier that I was going to probably have to add something here. But I had to fix my other problem first before I got to it. So here we go. When the 0 happens, the note gets released. Yeah, we do want to bang this, but we also want to stop this. So I needed to disconnect that because we're going to make another mechanism here. Here we have TBFF. We're going to make it a TBBFF. Now you got to disconnect these because as soon as you add another one here, it changes the order. Okay, TBFF. This is when the note gets turned on. We do need a float value being sent here to multiply the amplitude, the peak amplitude, by whatever the sustained amplitude change factor is going to be. Okay? And we need the float value also sent here to pack to initiate the attack sequence. And then we have a bang that's hooked up here to delay. But we also need to make sure we need another bang here, and that's the second outlet now, to allow this message to, because we're going to have to put a spigot on the decay segment. So when the decay segment occurs, we're going to have our on and off for it, which will be a 1. You remember from before. Whoa, I made extra object. We have a 1 to turn it on. And a 0, turn it off. When the attack comes through, we need this spigot to be open. So it's connected to the 1. That means the note's been pressed, so spigot should be open, ready for the attack to come through. But if a 0 comes through, which comes out of here, so I'm going to make a trigger bang bang, make it clear. First thing that happens, this bang here gets connected to this 0 here to close the spigot, so that the decay time doesn't get sent in case it hasn't been sent. Now, if it's already been sent, like if this 0 comes through after it's been sent, then there's no problem. And then the other bang there connects to this pack, which does the release segment. But basically, we need to stop the decay segment if it hasn't happened yet. So that way you have the option of releasing the note. Where are we going? Line. That way you have the option of releasing the note before the decay happens. So now, you hear that? I can play really short notes. The release happens whenever I release the key. And there's our attack, rise, and decay portion down to the sustain level. We now have a working ADSR. Yee-haw! Now I'm just going to arrange this so it's easier to see what's connected to what. Because if you have something connected to the wrong inlets and outlets, it's going to work. That makes it a little easier. Let's lower this stuff a bit more so those lines, you can see what's coming out of what outlet. You got to be able to make sure things are coming out of the right outlets. This delay, let me put it over here. Okay. But this isn't delay, this is the trigger bang float that goes with this. This should be up here next to this. Can you see what's coming out of what outlets? Yes. Alrighty. So that's the way it goes. Now what you can do with this, I'm going to close this. What you can do with this is basically, and I'm going to save it now that that's closed, so the next time I open the patch, it just opens this. Let me try a different sound. Now I want a quicker attack and a shorter decay, so we should hear a more, a pronounced beginning, but it shouldn't last that long. Now I don't want it to go down so quietly to that low of a sustain level. Let's put it here. There we go. Now let me arrange this so we can get a nice screenshot. We now have a working ADSR for our edit mode, for our synthesizer. I'll just put this here for now. Oh, eventually we're going to have to make this thing look a little nicer, but we have more things to add, more stuff to learn before we get to that point. And I'm going to get a screenshot of this. And that ends our episode for this week. I'm sorry it took me a little bit to figure that stuff out there, but that's all part of the game. I mean, even after a while of using pure data, you do get, things that kind of throw you for a loop because you hook up something wrong, or you kind of like are thinking one thing and do something else, and you hook something up to the wrong patch cable and all that. And basically that's what I did. I had it hooked up to the wrong thing to trigger the event of the delay. And so, what you got to do is things like I did there to kind of trace down what was the cause. And so you trace down what the cause is, and then you can fix your problems. Alrighty, well, that's it for this week. Thank you for joining me. Please do subscribe if you'd like more content like this, and hit that like button to help me out with helping me get more views and stuff. This is going to be a series that will continue to go on, and we're going to have a lot more in-depth topics to come. But in this season, we're just building a simple synthesizer. This is the foundation for everything else in this series that will be coming up. So let's get these videos circulated as best we can. Thank you very much, and take care. I'll see you next time.